Back in Unit 3, and I think Unit 2, you learned a bit about the Pythagorean Theorem. A squared plus b squared equals c squared. We even talked you through the math that got it there. So what we say is a leg squared plus a leg squared equals a hypotenuse squared. Now remember, the hypotenuse is always opposite the largest angle, which is the right angle. And it does not matter the order of the legs because they could be a squared plus b squared or b squared plus c squared or plus a squared. So it's leg squared plus leg squared equals hypotenuse squared. We're going to solve for the answer. Well, one leg is x, one leg is 10, and one leg is 19. So now you're going to do the math. We're solving for this missing leg. So we know that x squared plus 100 equals, and I have to do math for 19 squared, equals 361. Whoops, not 316. $361. Do the algebra. And we have crosses out. X squared equals 261. So x equals the square root of 261. And if you'll notice, it says round your answer to the nearest hundredth. So let's find the square root of 261. That is 16.15549, etc., etc. Remember, underline where you want, and then look if you have to round. X is approximately 16.16. Okay, that's using the Pythagorean theorem. Now remember, the x does not have to be the hypotenuse of the leg. So many times students have put the two numbers as a squared and b squared, not looking at the position. So let me remind you. Leg, hypotenuse. Alrighty? You need to put your variable in this equation based on whether your variable is a leg or is the hypotenuse. Let's find the side length of the next one and round my answer to the nearest 100th. I'll round the answer to the nearest 100th. This is a leg, and hypotenuse. So let's do the math. Leg squared plus leg squared equals hypotenuse squared. So 10 squared plus x squared equals 11 squared. 100 plus x squared equals 121. Subtract 100 from both sides. Oops, no, not 1,000. That'd be a little different. Crosses out, and I have x squared equals 21. So x equals the square root of 21. And the square root of 21 is 4.58257, etc., etc. I want the nearest hundredth. So my final answer, x, is approximately 4.58. Okay? So using the Pythagorean theorem isn't difficult as long as you remember what each part means. Next page, we're going to use it. We call this with indirect measurements and with involving word problems. Word problems aren't bad. Word problems are just logic. So we have a 12-foot ladder leaning against the side of a house. The bottom of the ladder is 9 feet from the side of the house. There we go. How high is the top of the ladder from the ground? That's a fancy way of saying how high is that side or how long is that side. Round your answer to the nearest tenth. Leg, hypotenuse, leg. X squared plus 9 squared equals 12 squared. X squared plus 81 equals 144. Subtract 81 from both sides. X squared equals 63. So x equals the square root of 63. Now, we could actually factor this and put it into rational square roots, but we want round your answer to the nearest tenth. So that means use your calculator. And you'll have the calculator in Alex, which would be x is 7.93725. Round it to the nearest tenth. X is about 7.9. That's not so bad, is it? Alrighty, now you're going to learn about special right triangles. Now we call isosceles triangles, which are 45, 45, 90, and 30, 60, 90 triangles special because there are some little tricks you can use to calculate the sides. Now in a special right triangle, the hypotenuse is obviously the hypotenuse, but each angle is 45 degrees. Each leg of the triangle is a number, and the hypotenuse is the leg times the square root of 2. So if I say, well, let's do this. Find x. If this angle is 45 in triangle ABT, T is 45, so A is 45. That was sloppy. It has to be 45. Why? Because there are only 180 degrees in a triangle, and there's only 45 degrees left. So we are pulling in stuff that you learned about triangles. All right? So AB is 8, BT has to be 8. And by the property of special right triangles, you don't have to do any math. X is 8 times the square root of 2. Now that's awesome when you know the leg and you're finding the hypotenuse. But now we know the hypotenuse, we want to find the leg. If you know the hypotenuse of a 45, 45, 90 triangle, and you want to find the leg, you divide the whole hypotenuse by the square root of 2 to find the length of a leg. So let's do this. Hypotenuse is 10. Dividing it by the square root of 2. You learned how to do this last day. We have to rationalize. 10 square root of 2 over 2 because we multiply the numerator and the denominator by the square root of 2. Now we can reduce 10 over 2. This becomes 5 square root of 2. So x is 5 times the square root of 2. All right? So you are given the hypotenuse, divide by the square root of 2 to find the length of the leg. You don't need a calculator. We call these exact answers because they are fractions, or sometimes not fractions, but we're not doing decimals. All right? We are doing this without a calculator. We are writing our answer in radical format. Look at ABT again. When you are given the length of a leg in a 45, 45, 90 degree triangle, you multiply by the square root of 2 to find the hypotenuse. When you are given the hypotenuse in that same type of triangle, you divide by the square root of 2 to find the leg. And sometimes you're going to have to rationalize. All right. Now we have another special right triangle, a 30, 60, 90 degree right triangle. All right. It is special because it also has rules. It has tricks up its sleeve. So here we go. If we're given the shortest leg, that'll be our x. The long leg is x times the square root of 3, and the hypotenuse is 2x. That's kind of cool. So if you're given the hypotenuse, then you go the opposite way. You divide by 2 to find the shortest leg and divide by the square root of 3 to find the other leg. So let's see what we're given. We are given the shortest leg. How do I know that? The shortest leg is opposite the smallest angle. You learned that in Unit 3. The shortest leg is opposite the smallest angle. So here, the shortest leg is 12. To find the hypotenuse, I multiply by 2, so x is 24. 12 times 2. Now in the next triangle, we are given the longest leg, and we have to find the short leg. We follow the rules. Divide by the square root of 3 to find the shorter leg. 10 divided by the square root of 3 becomes 10 times the square root of 3 over 3, and there is no way to reduce that. There are no common factors. So x, and this is not kind of messy, x is 10 times the square root of 3 over 3. That is the exact measure. Now, we're given the long side. We need to find the hypotenuse. Oh, that's a different one. Well, we still can do it actually kind of easy. It's a two-step process. Divide the long side by square root of 3 to find the short side. So I'm going to label this step 1. 8 divided by the square root of 3 becomes 8 times the square root of 3 over 3. And that is the length of the short side. Step 2, over here, up top. I take the short side, I multiply it by 2 to find the hypotenuse. So because we have a fraction, I'm going to say 2 over 1 times 8 square root of 3 over 3. Multiply the numerator straight across. 16 square root of 3 over 3. And I cannot reduce that. So the hypotenuse is 16 times the square root of 3 over 3. It looks super messy, but it's right. So don't worry about that. Again, we call these exact answers because they are not written in decimal form. They are written in radical form. And the square root of 3 is an exact answer. The decimal format is an approximation. Alrighty, so let's find these exact answers, different colors. This is a 30, 60, 90 triangle. I have my shortest side. I am looking for B, which is the longest side. I multiply it by the square root of 3. So it's 8 times the square root of 3, and that's all I need to do. Okay, now in my isosceles, my 45, 45, 90 triangle, I have my hypotenuse, which is 6. To find C, I divide it by the square root of 2. But I cannot leave it like that. I must rationalize it. So I'm going to do the work up here. 6 over the square root of 2. I'm actually going to show all the steps because I have the room. Equals 6 square root of 2 over 2. I can factor out a 2. There's a 2 is a common factor between those. And that becomes 3 square root of 2 over 1. So C is 3 times the square root of 2. Not really that bad. If you go through the steps and follow the guidelines we have for special right triangles, you're not going to have a problem at all.